It is said, coming together is a beginning, keeping together is progress, working together is success. On this note, good morning, ladies and gentlemen. I am Vaishnavi Khade.
And I am Girish Chandrasekhar. We are your hosts for today.
On behalf of the organizing committee and Center for Functional Materials, Vellore Institute of Technology, Vellore, we feel privileged to extend a warm welcome to all present here for the inauguration of the International Conference on Functional Materials for Future Technology 2023.
Today, we take pride to welcome Dr. Mailswamy Annadurai as our chief guest for the inaugural session. Popularly known as the Moon Man of India, he was the former director of the Indian Space Research Organization's Satellite Center in Bengaluru. We welcome you, sir.
We are also fortunate to have with us Dr. R.J. Will, Dean Alagappa College of Technology, Anna University, Chennai, as the guest of honor. Thank you, sir, for your precious time.
I am profusely elated to take this opportunity to welcome our Honorable Founder and Chancellor of Vellore Institute of Technology, Dr. G. Vishwanathan. We also welcome Mr. Shankar Vishwanathan, the Honorable Vice President of Vellore Institute of Technology. We welcome you, sirs.
Also, we are pleased to have with us the Vice Chancellor, Dr. Ram Babu Kodali, the Pro Vice Chancellor, Dr. Pathashafi Malik, the Registrar, Dr. T. Jabardi, the Director of Center for Functional Materials and Convener of ICFMFT 2023, Dr. R. Eriviri, and also Dr. Ramesh Thamankar, the Convener of International Conference on Functional Materials for Future Technology 2023. We warmly welcome the distinguished scientists and researchers joining us online and offline from India and abroad who have graciously accepted to share their knowledge and expertise with all.
നീരാറും കടലൊടുത്ത നിലമടந்த കിഴലൊഴുകും സീരാരും വർണ്ണമെന തികഴ്വരതം കണ്ടമിതൾ നിക്കണം മജസിരന്ത ദ്രാവിഡ തിലകമുമേ அத்திலகும் வாசனை போதனை துலகும் பின்பமுற
Thank you, Mr. Arya Swami and Ms. L. Srimati. We request everyone to take their seats. To make this morning a blessed one, to invoke Goddess Saraswati to kindle the lamp of the Kutuvilaku.
Thanks to all the dignitaries. We now invite Dr. R.L.V., the Director, Center for Functional Materials and convener, International Conference on Functional Materials for Future Technology, to deliver the welcome address.
Thank you. Honorable Chancellor, respected chief guest of today's inaugural function, Mailswamy Annathare, respected guest of honor Dr. R. Jaivel, Vice President, Vice Chancellor, Pro Vice Chancellor, Registrar, invited speakers from various countries across the globe, deans and directors, both online and offline. Good morning, everyone. It's my great honor and pleasure to welcome you all for this International Conference on Functional Materials for Future Technology. I wish to extend my hearty welcome to our chief guest, Dr. Mailswamy Annathare, former Vice President, Moon Man of
respected Vice President, Vice Chancellor, Pro-Vice Chancellor, respected Registrar, convener of this international conference, Professor Elil Willi, Dr. Ramesh, other dignitaries of the dais, invited speakers, participants from various institutions. Indeed, I am very much delighted and honored to have been invited for the inaugural function of this International Conference on Advanced Functional Materials. As many of you know, I am a very frequent visitor to this campus, and this is a very unique occasion addressing the inaugural function of this great conference. At the outset, I would like to congratulate the convener and the team of faculty members for choosing this very important topic of discussion for this 3 days conference. As it has been already narrated, that advanced materials, advanced functional materials play a very major role in advanced technologies. And if you look into the 3 major challenges which we are facing today globally are energy, environment, and healthcare. And these advanced materials, advanced functional materials contribute very greatly to address all these 3 challenges. And today we have materials which can bring the sunlight to a closed room like this. And we have materials which can have the mechanical strength, which is almost 25 times stronger than high strength steel alloys. And we have materials which can have almost 3 orders of magnitude with higher conductivity than the conventional copper, which we use for transmission purposes. We have materials which can have a surface area of close to 3,000 meters square per gram. 1 gram of materials will have a surface of 3 square kilometers, which can be useful for various applications. So all these materials were possible by properly analyzing their functionalities and properties. And sometimes if you look into the age-old materials, which will have that very new faces with a variety of applications. Let us look into the carbon. So, we cannot predict the age of carbon. It is said that the carbon would have born when the universe was born. Such a material has got different dimensions. We today talk about different material, derivatives of carbon like graphite, diamond, fullerenes, carbon nanotubes, aerosols, carbon aerosols, or activated carbon. Now, all these materials are now having very high applications in advanced materials. That's what carbon is also known as the black gold. And all these materials, when we properly study and understand the properties, then it directly contributes to various applications. And let us look into the diamond. The diamond is known for more than 1.5 centuries now. And mostly the diamond was used for both ornamental as well as jewelry applications. But today, the diamond has its electronic and thermal properties, which can challenge the well-known champion materials like silicon carbide and gallium nitride in advanced technologies. By realizing this, worldwide, there is a lot of efforts in studying what is called the lab-grown diamonds. And the government of India also has taken a very major initiative. And there is going to set up a very massive center at IIT Madras with a grant of around 242 crore. It was just released last month budget as a very special scheme by the Prime Minister of India. And Professor Ramachandra Rao has been given this massive grant at IIT Madras to look into the technological evolution of the diamond or lab-grown diamond-based materials. Fortunately, you are going to have Dr. Ramachandra Rao here on the final day of this conference, and he would give more details about that. And all these developments would happen if we have properly analyzed the functionalities and properties of these materials. I'm very impressed that VIT has these kind of world-class facilities to study all the properties of these materials. And I am sure the deliberations of this 3 days conference would be very immensely useful for those who are already practicing these advanced functional materials, and also for the young students who are planning to take up their research in this direction. I once again congratulate the organizers and thanking them for inviting me for this conference, and wish you all the very best. Thank you very much.
Thank you very much, sir, for listing out the variety of applications and infinite possibilities of functional materials. Thank you for motivating us. We look forward to hearing more from you, sir, in the plenary session. Now, we request our Honorable Founder and Chancellor, Dr. G. Viswanathan, to deliver his presidential address.
Good morning. Our chief guest of today's international conference on functional materials for future technology, Dr. Mailsamy Annadurai. Our guest of honor, Dr. Jayvel, Dean of the AC College of Technology and University. Respected Vice Chancellor, Vice President Shankar Viswanathan, Pro Vice Chancellor Dr. Parsadi Malik, Registrar Dr. Jayabharati, the Director of the Center, Dr. Edilvedi, Dr. Ramesh, the convener, other co-conveners, professors who come from various universities and colleges, participants, and other dignitaries, very good morning to you. I am so happy that this 3-day conference is being arranged by the team led by Dr. Edilvedi. A country's social and economic development is directly proportional to the investment done on education, science, and technology in the country. In particular, the amount of money spent on research and development will help the nation to advance in all frontiers. For example, after the Second World War, countries like Japan and Germany have invested heavily in research and development, both in academic institutions and in industry. Now, in the span of 6-7 decades, both Japan and Germany are leading in the areas such as nanotechnology, nanoelectronics, biomedical engineering, etc. Where we are lagging behind as a country is both higher education and research, science and technology. For education, we have been demanding that 6% of the GDP should be spent on education. We haven't crossed 3% yet, even though we are 75 years old after independence. As far as research is concerned, we are still poor. Countries like South Korea and Israel, they spend more than 4% of GDP on research. Other countries like US, Germany, etc., they spend more than 2% or 2.5%. Even China spends more than 2%. But we spend less than 1%. To be precise, 0.7% of the GDP on research. That is why in research and publications and patents, we are lagging behind. For example, they say 1 million for 1 million populations, how many patents are produced by each country? The highest is South Korea with 2,100 per million. Second comes Japan with 1,800. Third, USA with 950. Next comes China with 296. And ours is just 6 for 1 million population. So it is time now that we realize the importance of higher education, particularly science and technology and research, and spend more on them because it requires both the academic institutions as well as in industry. The government has to spend and also the private industries has to spend. We have witnessed how a committed pool of scientists can bring about a development of vacancies in short duration during COVID time. To achieve such a goals in other areas of science and engineering, government needs keep aside large corpus of research and development activities in universities across the country. There should be a sustained funding opportunities on futuristic ideas and research activities. For any product development which is beneficial to the society, a fundamental understanding of materials used in the product is very essential. That's what Professor Jaiwal is talking to us about. There are a few steps involved in such design materials, understanding the functionality of these materials, and possibly redesign the materials for multi-functionality of finally coming up with the product. I believe that we are a cusp of new age functional materials, which the potential to solve world problems such as energy storage, environmental sustainability, and healthcare. The functional materials with their better material properties are need of the hour. India is one of the leading centers for semiconductor design companies. Most of the global semiconductor design companies have their R&D centers in India. This is because India has a unique advantage of having exceptional talent pool of 20% of world's semiconductor design engineers and has highest number of patents registered in India because of them. So it is time now that we realize the importance of this, and that's why the AICT, All India Council for Technical Education, has recently introduced courses in semiconductor technology such as VLSI design, IC integrated chip designing, semiconductor management, silicon chemical extraction, among others, to produce skilled professionals who can contribute to the manufacturing and designing of microchips. These courses will create an immediate workforce in the country who will be able to contribute to the semiconductor industries in India as well as other countries. In this regard, this conference on functional materials will be a major step initiated by the Center for Functional Materials under Dr. Iribari. I hope this conference will create an atmosphere to bring in dialogue between the VIT, various institutions participating, and industry. By working together and sharing our knowledge, expertise, and ideas, you can unlock the full potential of functional materials and create a better future for all of us. I thank the organizers of the conference for taking the initiative in getting all the institutions and industries from outside the country also. I congratulate all of you. I wish the conference all success. Thank you.
Thank you, sir, for highlighting the current research scenario in India and worldwide. With your strong support always, we feel confident to keep marching forward in conducting high-quality research. Thank you for your generous support to the conference and Center for Functional Materials throughout. Now, we request Dr. Ankur Rastogi, co-convener International Conference on Functional Materials for Future Technology, to introduce our chief guest.
Respected Chief Guest, Honorable Guest of Honor, Honorable Chancellor, respected Vice President, respected Vice Chancellor, respected Pro Vice Chancellor, respected Registrar, and all the audience present here who joined us offline and online. Good morning, I am Ankur Rastogi and happy to introduce our Chief Guest for today's inaugural event of International Conference on Functional Materials for Future Technology. First and foremost, I would like to extend my warm welcome to our respected Chief Guest, Dr. Malayswamy Annadurai, fondly called as the Moon Map of India and former Director of ISRO Satellite Center and former Vice President of Tamil Nadu State Council for Science and Technology, who graciously accepted our invitation to be with us for this event. Dr. Malayswamy Annadurai is a remarkable individual who has achieved great success in the field of space and technology. Dr. Malayswamy was born in Kothavadi, Tamil Nadu. He had his schooling in his native village and higher education in Coimbatore. After completing his studies, he joined ISRO in 1982. His education is within 23 kilometers in the radius, while his satellites travel 230 million kilometers from the Earth. Dr. Moleswamy Anandarai worked various capacities at ISRO for 36 years and was project director for Chandrayaan-1 between 2004 to 2008, which is the India first moon mission. With the success of first moon mission, he was appointed the project director of the Chandrayaan-2 in 2008, and he also served as the program director of the successful Mars orbiter mission, which is also known as Mangalyaan. From 2015 to July 2018, he became the director of URL Satellite Center, formerly known as ISRO Satellite Center in Bangalore. He played a key role in production of more state-of-the-art satellite in lesser amount of time and money. For his numerous innovation steps, we were like standardization of the satellite hardware systems and making supply chain management more effectively. And due to this, it has become possible India can launch 18 satellites annually from 2018 onwards. He foresees that one day India can launch one satellite per day. He also is an acclaimed writer, and his book Kaya Ruke Nila won the SP Aditya Literacy Award in 2013. Few movies are also produced depicting his life, and most recognized one is Mangal Mission, where his role was played by actor Akshay Kumar. With his noteworthy achievement, Dr. Moleswamy Anandarai was conferred with Padma Shri, the fourth highest civilian award given by Government of India in 2016. He also received Rajyotsava Prasastis, which is second highest civilian award given by the Karnataka government for the science in 2008. ISRO has awarded him number of times. Some of them are Excellence Award 2010 as a team leader of Chandrayaan-1 and ISRO Outstanding Achievement Award in 2014. He has been a source of inspiration to many. His words and wisdom encouragement undoubtedly motivate all who are present here as well as who joined online. Let us give big rounds of applause to welcome our Chief Guest of Honor. Thank you, sir, once again for being with us, Dr. Moleswamy Anandarai. We honor you with have. Thank you.
Thank you, sir. We humbly invite our chief guest, Dr. Moleswamy Anandarai, to deliver the inaugural address.
Respected Chancellor of VIT University, Vice President, Vice Chancellor, Pro-Chancellor, Registrar, and the convener of this particular international conference, as well as the Center for Functional Materials, faculties, the invited speakers, students, researchers. I'm really happy and humbled to be chief guest of this particular event today. I have absolutely no pretension to be an expert of these functional materials. But as the guest normally makes use of whatever being served. He has no role in the kitchen. Somebody makes it and he eats it. I think I'm taking that role because being a person who worked in ISRO, there is a dire need of the functional materials for various needs in the space. It should be lightweight, but it should reflect its own behavior requirements in the space. So that way, definitely, we came out with basically talking about composite materials and even the smart sensors. And you talk about even the alloys of various natures called for in the space environment, or even the materials, even the systems which take the system to the space, starting from the launch pad all the way to going over there. Very various intricacies what space is asking for. Definitely materials were coming out, and that's how today we look at here. Yes, Chancellor is told with respect to research, various indices probably may be indicating India is the bottom line. But I think with all the modesty I can tell you, India can have mostly tell we are in the frontliners, at least in some technologies. I think the space is one of the things. Definitely it is there. And there, definitely the functional materials played reasonably good role, So that's the way I am basically, my presence is basically to acknowledge how the functional materials have helped for Indian space to reach that level and ambitiously placing itself how to move about the future. I think that's the way you look at here. Today, we are not talking about functional materials pertaining to the future technology. So when we talk about the future technology, you look at here, whatever when we talk about in the whichever the field, if you talk about science is considered to be even the academic institutions somewhere in the higher pedestal kept. And with that we'll tell rocket science considered to be. Okay, something if we tell something, if it's difficult, not rocket science, that word itself tells probably it is some intricacy sitting there, some complexity sitting there, some difficulty sitting there, probably it may be indicating. Yes, it was the case because when you talk about the launch vehicle, it has so many parts. And even the satellite, which will work in the space, in the hard environment of high vacuum, hard environment of thermal regimes, hard environment of radiation. And these systems also, though it's a mechanical system, electromechanical system, electronic system, they have to work in cohesion. Then only the systems can be declared as a working and being success. And while talking about this from launch vehicle, many intricacies are sitting there. So when you may, and that too, some of the systems cannot be tested before it be launched. It's a basic thing is you may test it a similar system, but the system which will be launched is a fresh one. That only will be launched. But if there make some mistake, definitely an issue, because that way, when you make the technology, you have so many intricacy parts that work together. And when you are making, as a technologist, you have to ensure that the given tolerances are kept in a properly, reasonably good way. But that is one of the reasons the rocket science considered to be a complex system. But the future technology, emerging technology, the one which is trying to take this fading away is the 3D printing. Okay, instead of making so many thousands of parts within tolerances and assembling them together with the different types of materials, different types of tolerances, different types of geometric systems, and which could not be tested in a functional final mode, and that's be launched. That is one of the reasons, the difficulties. So now, is it possible to print the whole rocket system itself? I think that's how we're talking about that. So theoretically, yes, printing, people have shown that, but functionally it calls for materials. Okay, the functional materials which can be amenable to the 3D printing, but still it can withstand the highest temperatures, vacuum conditions, radiation environments, whatever all I talked about that. Those things are not changing, because just because a 3D printed rocket versus a normal rocket, environment remains same. Okay, that keeping that in mind, if you are able to do it, definitely it makes a small level people have done it. But now during a COVID, I think after COVID, I think this may be one of the first face-to-face conference here. Now we look at here. But that means the COVID has made so many hindrances, the way in which we are getting educated, the way in which we are meeting. But notwithstanding that, believe me, the last 65 years, how many satellites have launched to the space? More than 50% of that numbers of satellites have launched last 3 to 4 years. Okay, that basically what it indicates is today's future technology. When we're talking about here the semiconductor, yes, the invention of the semiconductor made a lot more difference over the last 60-70 years. I think the semiconductor itself, we're talking about transistor, is not more than 75 years old. Okay, but that made such a revolution, correct? No? But now similarly, that computers have came and the computing systems have came, AI we talk about, so many things we're talking about there. But the emergence of the communication, which we are handheld system, which we are not even a decade old, now it is going to take a quantum jump with these satellites, what we are talking about, it's more than 5,000 satellites being launched last 3 to 3.5 years. This is going to connect everyone to everyone, everyone to everything, everything to everything. That means wherever you are, wherever your systems are there, that connectivity is going to happen. This connectivity will make the way in which we negotiate, the way in which we work, the way in which we function, I think it's going to change a lot more. Okay, when that such things are happening, That means future technology, when we're talking about that, space is emerging one of the things in your connectivity point of view. The mobility, when we're talking about here, the two-wheeler or three-wheeler or four-wheeler, your aeroplane, many things we talked about there. I think similar way, the connectivity also is coming a part and parcel of our daily life. And beyond that, this connectivity is yes or today, wherever the cell phone towers are there. Okay, only very few people, very few percentage of people are privileged to have wherever you have the thick density of population. The population density is less, it's not connected today. But the satellite is going to make that difference. That means in the globe, it's going to be like a web, it connects that way. So, but when in that future technology, you have many, many things to be a function, as I told there, no? The functional way to do it. That means a day in, day out, the satellites need to be produced, to be launched, because when you have 6,000 satellites sitting there, definitely a satellite or one day or other will keep losing its functionality, losing its life. So that means it has to be replaced by another satellite at the immediate effect. Okay, so that too may happen. You should be ready to make the satellite in a faster rate. You too should be ready to make the launch vehicle in a faster rate. You should be ready to launch it and replace it in a faster rate. These opponents are totally different technologies of future. So to meet that, definitely we need a good amount of functional materials. And that amounts to say various ways. For example, as I told, I am the like user when we're talking about one of the satellites when we are launching, even for Mangalyaan we are launching, you would have seen Mission Mangal. Okay. And the Mission Mangal, the particles are coming and hitting the antenna and it's piercing through. It's many things they talk about that. You look at there, the way in which you have done, the satellite has been configured, the configuration into one side the solar panel, another side epic antenna. That antenna must be able to take the two different frequencies, two different ways. That means antenna remains same because functionally you cannot have the multiple antennas. The might is more, many things are there. But you are trying to articulate one side solar panel, one side your antenna. This en route for the 9 months when you are going also, we are functionally trying to make as if the sailing into the space with the minimum fuel you have to go. I think that's what we've done. For that, it calls for we can have only one antenna, but we have to operate two frequencies. That means it calls for two antenna. Functionally, two antenna required, but you should arrive at a single antenna, do the same function, RF function point of view, but other the articulation also it will do beyond that also. This is the way functionality we brought in Mission Mangal. That's how we're talking about very unique way whatever we have done. So for that we used to have antenna remains geometrically remains one. But we created two different surfaces, functional requirement, two different surfaces. One surface just sitting in the behind will allow a shorter frequency to be reflected first. Another one will, second frequency will do. That means one over other two materials, lightweight materials, functionally to meet that requirements has been realized. Like that you look at here, the need of the hour, it was pushing to get that functional materials and trying to do that. Similarly, now you look at here, gone are the days. I think even for the medicine, like whatever I'm wearing a coat, the same coat Shankar cannot wear. Correct? No? Shankar's coat I cannot wear. Each one has to be stitched for their own requirement. Medicine also has to be called for like that. Not only that, very many things in the future technologies, people are not generally thing not possible. You have to have custom made thing, starting from your cert. Everything, even for the medicine, it's a requirement is going to come. Even for the building or vehicle, very many things is going to happen there. So to make that, this whatever I told, the 3D printing is going to be there, very many facets. Okay, even the specs will be 3D printed. Now, somehow we are on average sense, we are making use of it. But beyond that, for each specific to the person, things to be done for that. When that's the requirements are coming, definitely how the functional materials which amenable for 3D printing, that even though for 3D printing point of view, it calls for some nature, but final product point of view, it calls for some other functional requirement. This connectivity is point of view, definitely we need to have into many things. But while talking about here, recently, when I went through that literature, it talks about, even for the vaccine, you may be knowing that, even for the COVID vaccine point of view, to screen out many of the possibilities, many of the formulations, software systems are used, data analysis are used, AI was used, like that we are told. Similarly, even the functional materials also, today it is coming out in a big way. For example, when you are talking about the smart alloys point of view, I think I have been told it is being talked about nearly once in a decade. That is what you call safe memory alloys. Safe memory alloys has been identified. But you really look at the way in which the new safe memory alloys have keep forming out. It is taking nearly a decade-long journey. But today, that is being accelerated using AI and data analysis system point of view. That is being talked about. That is how we talk about a vaccine formulation point of view. That is how we are able to do it in a much better, faster way, instead of waiting for a decade-long wait. It has happened there. Similarly, I think we are talking about the new materials also. People are talking about a new results started emerging that way instead of going a conventional trial and error. Conventional trial and error versus many things is possible using a computational way. People are talking about that. Beyond that, you're talking about energy conservation. We talk about in a way, this again, the space. There was a time we talk about theoretical possibilities. I think even Kalam was trying to push that concept in a big way, but somehow it would not happen. Possibility exists, and the need also may happen there when the fossil fuels are keeping going down. Definitely, we should identify another energy resources. Various things are going on there. One such thing being the solar energy. Solar energy in the ground. In the ground is concerned, not more than 6 to 7 hours. Okay, at the maximum, you can 10 hours, you can have the energy, but remaining 14 hours or 15 hours is not there. And again, it is not year-long thing. That means whatever we do in solar energy in the ground, you need energy storage system. The energy storage system is another big question mark we are talking about, how we are going to salvage this. Is it what if alternate solution? Alternate solution, that's a future technology when we're talking about this concern. No, it was talked about. Probably this was driven to the wall. We have to go like that. It may happen. So as I told, no, whatever the faster rates, in spite of the COVID, we could launch the satellites, thinking post-COVID, so many things are going to happen. It's happened there. Similarly, this fossil fuel is going out, and the solar energy, it has its own limitation in the terrestrial way, what you are connecting, irrespective of the fact, whatever quantum dot, whatever they do, efficiency will improve. But you don't have the longer duration of the solar energy available in any part of the world. So that if you go to the space at 36,000 kilometers, you have uninterrupted 24/7 solar energy available. Okay, but still, as I told previously, it should be a lightweight system has to go to the space. And that means it has to go and do a slightly different way, much different way. Once upon a time, as I told, thousands of parts to making a satellite versus one single 3D printed rockets can be made today when you're talking about. Similarly, is it possible to have space-specific solar systems? Okay, efficiency should be better, but there even without efficiency also, for example, here ground we are talking about 300 watts per meter square is a typical number we talk about the solar energy. But in a space, if you go, it is easily 30, 50, it nearly 4 to 5 times more than what we get here. We will get without any efficiency change. As it is, we can get it there. So, but with the slightly better efficiencies, if you do, so that area is available. From there, uninterrupted power, it's possible to get technology-wise point of view, people have enabled it. But to make that to happen, the future technologies, what we're talking about, the functional materials, so that lightweight systems we're able to put it there. So that area point of view will give, as Dr. Jayavir has given. So area point of view, it can be bigger, but mass point of view, it's slightly less. So that way we're able to come out to that, but still after going over there, it should deploy. So this is the requirement of that comes. This can solve in bigger way for the global future energy point of view. I think the possibility exists. And just I'm telling about these are the possibilities. Why I'm telling again and again space is, it is not we have to go to the space for the moon or Mars for colonizing money like that. You have today also the energy is point of view. If whatever maybe you talk about, energy is basically solar system. The sun is concerned, but that is very, very unperturbed when we are going to the space. From there, if a connecting point of view, I think we will be able to get a lot more things there. Like that, I think the future technology point of view, very many things are there. You can imagine a lot more. So connecting the future technology, functional materials, what all we can do it. I think that way we are able to spend the time there. Definitely, as the Chancellor has told, We may be missing in the indices point of view researchers, but there is a good possibility we can leapfrog. Okay, we are unless service you leapfrog, you cannot get that numbers 6 to he's talking about 22,800. The indices point of view, it's a very big gap. That very big gap to fill, you have to leapfrog. You keep walking or keep running, not possible. You have to jump. The jumping point of view, I think this space gives enough opportunity, connecting for the what is required for the tomorrow's energy, connecting how the connectivity of future is going to happen, and calling for how you can make it a faster, how you can make it the things better, how you can make the things cheaper with the available. Already you have an edge ahead of that. All putting together, it's possible. So that way, from my perspective point of view, the future technologies, what is called for with respect to energy, with respect to connectivity, with respect to space, with respect to many things point of view, definitely future technology requires. When the teacher technology requires to connect that, what is the functional materials, we can make it that way if you do. Definitely 75 years back, somebody came up with the semiconductor. That made such a revolution. Definitely we need another quantum jump to go up. Okay, so that is today India also needs that. We have the time, we have the energy, we have the things. And again, Chancellor has a very, very nice way. This is in a Vellore. Yesterday when we were talking about some of the foreign experts, how this place is like an oasis, it looks like. When they're traveling all the way from here and reaching to this campus, this looks like an oasis. How it has come? It is basically the vision of the Chancellor. And this oasis now is taking beyond this place. Chennai also something has come. And it is going for Amravati also is there. Bhopal also is there. It is again, morning he was telling about around 120 students started to start with this institution. Today, I understand, I think, yes, yesterday evening, Pro Chancellor has told more than 80,000 students across these 4 campuses, they are there. And his ambition is not stopping. Okay, basically what I'm trying to tell is, he is not satisfied with the 80,000. His immediate goal is 1 lakh, 100,000. Okay, so that 100,000 is not just sheer number. That is what really required. When that is not just the sheer number, he talks about the QS index of better than 200 I should get. And a research point of view, our people and the faculty should play a reasonably good role that way. So all putting together, it is not only the quantity, it's the quality. That's what today's India requires. Okay, I think towards that way, I think it's very well synchronized. So my best wishes for the success of this conference. The abstract also indicating what is going to come, and very well it is articulated there. So with that, my best wishes for every one of you. I think your register wanted the next Mailswamy to be in VIT campus. Even this Mailswamy also ready to be in VIT campus. Thank you, thank you, thank you.
Thank you, sir, for highlighting the significance of functional materials in space technology. We all feel proud about the India Space program and feel really happy that you addressed us today. You inspire us to leapfrog towards the bright future of technology with research on functional materials. Sir, you spoke of connectivity. We hope to stay you connected for valuable guidance in our future pursuits. Thank you, sir. I now request Dr. Ramesh Thamankar, convener, International Conference on Functional Materials for Future Technology, to propose vote of thanks.
Good morning, everybody. Thank you is such a phrase that cannot be seen or touched. It should be felt by heart. So I feel honored and privileged to get the opportunity to propose a vote of thanks on this occasion. Good morning to the most venerated chief guest of this inauguration function, Dr. Mailswamy Annadurai, fondly called as Moon Man of India, and our beloved Chancellor, Dr. G. Vishwanathan, our guest of honor, Dr. Jaivel, Vice President, Mr. Shankar Vishwanathan, Provost Chancellor, Registrar, dignitaries, delegates, participants, students, and my dear friends. I, on behalf of the organizing committee, convey my deep regards and hearty thanks to our honorable chief guest of the function, Dr. Mailswamy Annadurai. Sir, your presence has added incredible value to this event and the conference. We really appreciate you taking out your time for us from your busy schedule. Thank you so much. This event and the conference would not have been possible without the support of our beloved Chancellor, Dr. G. Vishwanathan. Thank you for giving us an opportunity to organize these events, sir. Your support has always made us think big and do things in grandeur manner. I'm very happy that Professor Javel from Anna University has agreed to come here to this occasion and give a plenary talk later in the day. On behalf of the organizing committee, I thank you for agreeing to give this lecture. Thank you so much. We sincerely thank Vice President, Vice Chancellor, Pro VC, Registrar for their constant support. We sincerely thank you for gracing this occasion. At this juncture, I should thank all the invited speakers who have come here from various places, who will share their wealth of knowledge and experience with the participants and students. On behalf of the conference organizing committee, I extend my sincere thank you. I'm sure you will have great time in the conference and here in VIT. I would like to thank all the speakers who are not physically present here, but will be participating in a conference via online mode. Finally, not the least, I thank all the participants who have come from long distances. We really appreciate your presence here in the conference. I hope you will have wonderful 2 days of conference filled with invited speakers, poster presentations, oral presentations, and discussions among your fellow participants and delegates. A big thank you for all the research scholars from the Center for Functional Materials who have been working tirelessly with us. I hope you will have great time in this conference. I sincerely thank Dean of School of Advanced Sciences, other heads of departments who allowed all the students to come here and observe this occasion. Finally, but not the least, I sincerely thank all the students from Physics Department, Chemistry Department, and various other departments who have come here to making this event a grand one. The acknowledgement also goes to the organizers of the CTS department and colleagues who have made this event live world over. Thank you, everyone.
Thank you, sir. I hope you all have enjoyed this inaugural session as much as we enjoyed hosting it. So let's carry this positive energy forward into the rest of the conference. We wish you all a successful conference. I request all the guests and participants to kindly gather for a photo session at the portico at the main entrance of this building. Thereafter, a high tea is also arranged in the quadrangle next to this auditorium. After a short tea break, I request all of you to join back here for the plenary talk at 11:30 a.m. Thank you all.
Thank you all.
இப்ப எதுவும் இது கிடையாதுல முடிச்சுல சரி அந்த இது க்ளோஸ் ஆச்சு சொல்லிட்டு சொல்லலாமா அவர்கிட்ட இல்ல இப்ப இவரு தானே கேட்டாரு இது அவள என்ன பண்றியா நீதான் ஓபன் பண்ணி வச்சிருந்தீங்க பண்றது